Hi everyone, in this video I'm going to use technology this time to make a model of the curve here on this logo, starting from the diver's armpit, curving along the front of the body and then around the foot and down onto the front corner of the fin. So I already have 4 data points which are here, C, D, E, F. That's nice. Remember in the last video we did an algebraic solution for a third degree polynomial, which is not a particularly good job, I must admit, so let's just make that disappear from view. What I really need is more data points. So I'll go back to the toolbar here and I'll just start putting some more data points in. Now we don't have to be silly about this, but we probably do need somewhere up around maybe 10 to a dozen. Going much beyond that wouldn't really do too much to increase the accuracy, so that looks like a pretty good list. And the next thing that's nice and convenient is to refer to all of those data points together rather than individually. So notice GeoGebra automatically names them alphabetically from the start, so C down to letter N, and data points or objects which are points have capital letter designations. GeoGebra is case sensitive, so we'd have to refer to this as capital C, not lowercase c, and so forth. Now I just want to make a list, so I just give it an identifier, list 1, and then I use curly brackets and I literally just type the objects. So putting caps lock on C, D, E, F, G, H, I, J, K, L, M, N. I think that was all of them, all the way to point N. There we go. Hit enter and we have an object called list 1. Don't forget to turn the caps lock off. Now there is, I want a function. I've already used a function called f of x. So I'll give this one the name g of x. Once again, you must use a unique identifier. And here's the great bit. The command I want is called fit poly. And as GeoGebra does, as you start typing the command, it gives you a list that match. Now there's 2 versions of the fit poly, a list of points followed by the degree of the polynomial. So I'll click on that one and it's jumped ahead to here. My list is list 1, so I'll type list 1, arrow key to the degree. Let's try a third degree polynomial. And you can see it's drawn the thing there. Look, it's a lot better than my first attempt because there's more data points to work with, but it's still not a particularly good match for the curve along the front edge of the diver here and around their fin. So a third degree? No. Let's try a fourth degree polynomial. That's getting better. Still not a great match. And you'll note obviously that this curve takes a little bit of a nosedive here on the left. Now that's beyond the point that we're interested in modelling, so it's outside of the domain that we want. Our domain will run from wherever point G is here at about point 7 up to this point, which is at about, what's that, probably about 5.5. So that's our domain. So really, do I care what's going on beyond that? Probably not. But a fourth degree, well, we might be able to do better. Let's try a fifth degree. Now we're starting to get somewhere, aren't we? I mean, this is looking like a pretty good job. It's a little bit bumpy here. Let's try a sixth degree polynomial. Now that is looking really nice along here, and it's maybe just a bit on the high side there, but it's curving beautifully down here to the corner of the fin, so that's pretty good for a 6th degree polynomial. Let's try a 7th. It's really only affecting what's happening outside. That didn't seem to have much difference here or here, really. So really that's up to you to make a judgment on what you want to do, but it's technology. Technology is helping us to solve this. So once I press enter, I can see my polynomial here. This is my 6th degree polynomial that has fitted this list of data points that I gave it to work with. How easy was that? The default for GeoGebra is only to display, I think, 2 decimal points. So if you need a bit more than that, then you can head to the settings menu, down to the main menu, sorry, and then down to settings. Then you can see here for rounding, if I do round to 2 decimal points, then that's easier to read, but probably not as accurate if I wanted to transfer that polynomial. 3 or 4 decimal points is usually more than enough for the sort of accuracy that we're looking at. And there we go. That's how you do a polynomial fit. And you can choose the degree to a whole bunch of different points. Imagine doing the algebraic solution with all of those points. It would take me a week to do those algebraically. This is why we use technology. That's all for now. Give that one a try for yourselves.